Now we'll take the next example, which is on page 4, and here we have a diagram. In triangle ABC, point D is on BC, on side BC. So point D is on the side of BC. It is not on any other side, but exactly on the same side as BC. So point D is on the side of BC. That means it is collinear. It's in the straight line. Now we have to find area of triangle ABD with ratio of area triangle ABD and is to ratio of triangle ABC. And the second one, we also have to find area of triangle ABD is to area of triangle ADC. But before we try solving this example, let's try to understand the concept behind this problem. There is one concept which you need to know. This is now point A is a common vertex of all the triangle. Now what is vertex? Vertex is a corner. For all the triangles, whether you take ABP or APD or ADC, for all the triangles, there is this common vertex. This one A is common. All the points on the base are collinear. All the points here are collinear. What do you mean by collinear? Collinear means when the points lie in a straight line. When all of them are lying in a straight line, then they are said to be collinear. Hence, the distance from point A to the base are the same. Since they all lie in the straight line, so for the distance from point A till down here, it's the same. Now, don't think that just because the line is here, okay, this line is bigger and how can the distance be shorter? But distance is, we are talking about the height. So, if you take this triangle, this obtuse angle triangle, if you look at it, you will say, okay, AC is quite big. AC is not the height. The height is coming here. And in this case, the height is AP only. So, even in the case of ADC, the height will be AP. Okay. So, all the points on the base are collinear. Hence, the distance from point A to the base are the same. For all the triangles, the base are the same. So, this is the concept you need to understand, that when there is a common vertex and a triangle is formed with the base which is collinear, then the height will be the same. Okay, so height of all the triangles are the same. Now let's try to solve the sum. So here you have point D is on the side of, I have already said point D is on the side of BC, and DC is 6. DC is 6 here. Okay, and BC is 15. The entire thing is 15. So you have this line here, BC is 15, BC is 15, then in between you have got P and you have got D. Now DC is 6. Okay, now we have to find the ratio of triangle ABD to ABC first thing. So first we will try to find the ratio. In order to find the ratio, we need to find the base and height. Now remember, in this triangle the height is the same. So we are going to take the formula A1 upon A2 is equal to B1 upon B2. Okay, what is B1 here? In the first triangle ABD, what is B? B is BD. Now, do we know the value of BD? We don't know the value of BD. So, we need to find it. So, how do we find it? So, in order to find it, what we need to do is, we need to use this measurements which are given. It's given. Okay, it's given BD plus DC is equal to BC. Right? Now, here you have BD plus DC will give you the entire thing, right? So we have BD, which is BD we don't know. We will write BD as it is. DC we know it is 6, and BC we know it is 15. So we will write 15 here. So BD plus 6 is equal to 15. Therefore BD will be 15, and when you bring 6 this side, here you have plus, when it comes this side it will become minus. So BD is equal to 15 minus 6, which is 9. Now we have to find B1 upon B2. So what is B1 in ABD? B1 is BD. And what is B2 in ABC? It is BC. How much is BD? BD we have got 9. How much is BC? BC we have got, it's given here, BC is 15. BC is 15. So 3 3s are 9, 3 5s are 15. So now we have got the first one. I'm just explaining the concept first. I know it's very untidy. First concept is we had to find area of triangle ABD upon area of triangle ABC. So we are using B1 upon B2, which is equal to what is B1? B1 is BD. See, I have already written B1 is BD and B2 is BC. How much is BD? BD is 9. How much is BC? BC is, it's given 15. Right, it's there in the question, 15. BC is 15. So 9 ones are 3 3s are 9 and 3 5s are 15. So the answer is 3 upon 5. So here you got the first answer, which is 3 upon 5. We'll understand once again neatly. So in this triangle, we have found the measurements. How did we find the measurements? The entire thing is 15. BC is 15. It's given here BC is 15. And how did we find BD? We wrote BD plus DC gives you BC. Then BD is how much? BD we don't know, so we wrote BD. DC is how much? DC is 6. It's given here DC is 6. And equal to BC. BC is 15. So we've written 15. BD is equal to 15 minus 6, which is 9. So now we got BD as 9. Now we are going to find the ratios ABD upon ABC. So ABD base is BD, right? Height is AP. This is the height. In triangle ABC, base is BC. Height is AP. I have taken this as AP common height. Now, what is the formula? B1 upon B2. So ABD, what is a base? BD. So we have written BD here. Upon B2. What is B2? BC. And BD, what is a BD measurement? We have found here 9, right? 15 minus 6 is 9. We've got it here. And BC is 15. We have got it in the question 15. And after cancellation, so answer we got 3 upon 5. We have solved the first part of the question, which was ABC, area of triangle ABD upon area of triangle ABC. Now we are going to solve the second part, which is to find the ratio of the areas of triangle ABD upon area of triangle ADC. So first we'll take the triangle ABD. In ABD, base is BD. Yeah, the base is here, BD. Height is AP. In ADC, base is DC and height is, now as I told you, height will be, this is an obtuse angle triangle, the height will be outside, and I had told you that the height is the same for all the triangles. So height is AP. Height is AP. Okay, now what are the measurements? BD, what is the measurement of BD? We have found that it is 9. So BD is 9. DC is 6. It's given in the question. DC is 6. And since the heights are same, we will use the formula A1 upon A2 is equal to B1 upon B2. Now what is B1? B1 is the base of the first triangle, which is BD, upon the base of the second triangle, which is DC. What is the measurement of BD? The measurement of BD is 9. And what is the measurement of DC? The measurement of DC is 6. Now we'll cancel. 3 ones are 3. 3 twos are 6, not ones are 3 twos are 6, and 3 threes are 9. 3 twos are 6 and 3 twos are 9. So the answer will be 3 upon 2. So the final answer will be area of triangle ABD upon area of triangle ADC is equal to, what is the answer? 3 upon 2. Okay, so this is the final answer. So let's understand it neatly. Here you have base triangle ABD, base is BD, which is 9, which we have found here by minusing 15 minus 6. That is, the entire thing was 15 and DC was 6. So minusing 15 minus 6, we got 9. So BD we got 9. Height is AP. Similarly, in triangle ADC, base is DC, measurement is 6, which is given in the question. Height is the same, AP. So we will use the formula B1 upon B2. Why? Because height is the same. So the property and formula 2 we will use. So A1 upon A2 is equal to B1 upon B2. So area of triangle ABD upon area of triangle ADC is equal to BD upon DC. So A1 is what? Area of triangle ABD, and A2 is what? Area of triangle ADC. And B1 is what? BD. B2 is what? DC. And what is the measurement of BD? 9. Okay, BD is 9 and DC is 6. So after you cancel, you get 3 upon 2. So this was the final answer. I hope you have understood thoroughly the solved example which you have practiced in this lecture and also understood the concepts. In the next video, we'll understand the solved example number 3, which is given on page number 4. Keep practicing and become an expert in maths too. Thank you, dear children, and God bless you.